So we've talked in the last video about how to determine whether or not we're working with a binomial experiment. But in this video, we're going to actually get down to the nitty-gritty and start computing. There are some expressions, I guess, that we'll use. We'll say the probability of a capital S, we call that the probability of success. And the numerical value that it is lowercase p. So for example, if success is flipping a head when we flip a coin, then the probability of flipping that head would be 1/2. Lowercase p would be 1/2 or 0.5. Probability of failure numerically is designated by q. So if we were talking about earlier probability of rolling a 3, we're not rolling a 3. 1 in 6 chance of rolling a 3, and so that would be a 5 in 6 chance of not rolling a 3. One thing to keep in mind is if we add p and q together, we should get 1. Because the binomial part of this is it's either yes or no. And so the probability of succeeding is p and of failing is q, and if we add them together, we've either succeeded or failed. That adds up to be 1. So oftentimes you'll see one of them written in terms of the other. We could say, well, then p means 1 minus q. N we're familiar with, that's the number of trials, the number of people in our survey, the number of whatever, n is still n. And capital X is what we use to denote the number of successes in our n trials that we've done. If I want to find the probability that I've had this many successes, okay, then the formula for that, and this in choose X, comes from the last chapter. In choose X, p meaning the probability of success to the x power, and q to the n minus x. Understand x is always a whole number value. We succeed 0 times, or we succeed 12 times, or we succeed 37 times, but we can't succeed 14.6 times. Alright, so without using this formula, let's go back to an experiment that we've done before, where we say we're going to flip a coin, and let's flip that coin 3 times. This is a tree diagram that we've drawn more than once, I think, already this semester, and I'll get it scribbled back up here again. We found all of these branches are equally likely, so that means I don't have to label them as I go. I'm making a mess. So we can say if we want to figure out the probability that I flip 2 heads out of those 3 flips of a coin. And when I say 2 heads, that means exactly 2 heads, remember, not 2 or more. I would say that if I wanted it. Okay, so that branch has 2 heads, that branch has 2 heads, this branch has 2 heads. And since these branches are equally likely, I can say, well, that means 3 branches out of my 8, I have a 3/8 chance. Remember, we would multiply, if the branches were not equally likely, we would have to label all the probabilities. Okay, let me get some in here. Now, just a few of them. And so if I were having to take that path, I would multiply. Say if I want to go head, head, tail, I would have to multiply these probabilities together. 1/2 and 1/2 and 1/2 multiplied is 1/8. Okay, this one would also be 1/8, and so would this one. Okay, we said if multiple branches fall into this category, this winning piece of this experiment, then we add them up, 1, 2, 3/8. If I wanted the probability of getting no heads, we find the number of branches that gives us that case, which is here. Cross my T. And so there is 1 branch out of the 8th, 8, or 1/2, 1/2, 1/2, which is 1/8. The probability of getting no heads at all would be 1/8. Maybe I want to find the probability that I get 2 or fewer heads. which means 2 heads here, which means my 1 head, which I haven't figured, which means no heads. So here's 2 heads, here's no heads. I would have to include 1 head, 1 head. Okay, and this is the only branch that isn't involved. Okay, if we count them up, I missed one. There's one. Okay, also 1/8. If we count them up, 7/8. Okay. Again, on this example, counting 2 or fewer heads, not a big deal. Counting 2 or 1 or 0. Okay, the only number that I didn't consider was 3. Okay. So I could look here and say there's only one way of getting 3 heads out of my 8 possibilities. And so 2 or fewer heads is the complement of getting 3 heads. And so if I want to take 1 minus the probability of getting 3 heads, okay, sometimes it's easier and shorter for me to find the complement of the event, and then I can subtract that probability from 1. I'll still find out there's a 7/8 chance of getting 2 or fewer heads. But maybe instead of flipping the coin 3 times, maybe I want to flip it 20 times. Can there space between 20 and times? Okay. I'm going to let success be flipping ahead. So the probability of success is denoted by lowercase p, and the probability each time I throw a coin flipping ahead is 1/2, or 0.5. I don't care if you use fractions or decimals here. If it was a fraction though, such as 1/3 or 1/6, maybe I'm rolling a die, then you need to use fractions. Otherwise, you're going to compound your error immensely if you rounded 1/3 to 0.3 or even 0.33. Okay, so fractions or decimals, if the decimal representation is short and sweet, okay, terminating. If the decimal goes on forever, leave it in fraction form. If the probability of success is 1/2, the probability of failing is 1 minus 1/2, which is also 1/2, or 0.5. The number of trials in my experiment is 20. And maybe the question I'm asked is, what's the probability that I flip exactly 10 heads? I know in a perfect world, if I throw that coin up 20 times into the air, it's going to land on 10 heads and 10 tails. But the probability of getting 10 successes, let me find my formula here. Okay, we're going to use this formula. N is our number of trials, choose X is the number of successes. So out of the 20 trials, I want 10 of them to be success. Then it says I'm going to take P to the X power, meaning 10 successes, and Q to that's 1 minus, or N minus X. Again, this with everything being even Steven. When I'm flipping a coin, I have a 1/2 chance, or 1/2's the probability of heads, 1/2 for tails. If I have 10 heads, I have 10 tails. But remember, P and Q, these exponents need to add up to N. Okay. I'm gonna go ahead, pause the video for a minute, type this mess into your calculator, and see if you can get the same thing I do. When you're done, I'll put it up here in a sec. This into my calculator, I got 0.176. The probability of getting 10 heads and 10 tails, less than 20%, but it'd be exactly half and half. If we want to know the probability that we would get exactly 15 heads, and out of the 20 flips of our coin, we want 15 of them to be heads. The probability of flipping a head is 1/2. Again, the probability of flipping a tail, also 1/2. That we have 15 successes and 5 failures. Go ahead and type that into your calculator and come back when you have the answer. We should get 0.015 out of that. Now maybe I'm asked, I need to write x equals 10. I do my pen. Sorry, I'm getting sloppy because I'm in a hurry. Maybe I want to know the probability that I flip at least 18 heads. That means I get to do the formula 3 times. I need to find the probability that I'm going to flip 18 heads. The probability that I flip 19 heads, that's a plus sign. And the probability that I flip 20 heads. Okay, so I get to use this formula 3 times and then add those probabilities together. Go ahead and pause the video, give that a shot, come back when you want to see the answer. Here are the expressions you would need to plug into your calculator. Do understand that 1/2 to the 0 power is just going to be 1. If we are getting all 20 heads, we don't have any tails. So type these into your calculator, get the 3 decimals, add them back up, and I'll be right back. Alright, so the probability that you get, teeny, teeny, eeny, weeny, tiny, it's really very unlikely that you'd get 18, 19, or 20 heads. Next video, we'll do some more examples.